Three, starting with the multiple choice. Number one, which of the following is a polyatomic ion? Well, for this, I'm going to go to table E. I'm going to remember that all my polyatomic ions are right here. So I'm going to take a peek. And I do see that this was one of the choices, dichromate. So I'm going to go with D, dichromate. 2, a chemical formula represents. So we have qualitative, quantitative, both, or neither. I never really liked neither, and honestly, I never really liked only. So I'm going to go with C. But really, when I'm talking about a chemical formula, I'm talking about something like NaCl. And from there, I know quantitative information, which would be things like mass or weight. And then I have things that are qualitative, like I would know that it's ionic, so it's probably a solid, things like that. So from a formula, you kind of know both. 3, consider the following unbalanced equation. When correctly balanced using the smallest whole numbers, sum of the coefficients is. So I'm going to focus that they want the sum, and I have to correctly balance it. So let's go through. I notice that I have 3 FEs right here, and I only have 1, so I'm going to go ahead and put a 3 right here. Then I'm going to look and say, okay, let's balance my O's. So I have 4 here, 1 here. Let's put a 4. And then I have now 8 H's. So I want to make this 8 H's, and we're all balanced. So I'm going to go 3 plus 4 plus, now here's the tricky part. There's really a 1 right here. So you can't forget that even though you didn't write anything, it's a 1. So plus 1 plus 4, and from there I get 12. See? 4, as an endothermic reaction occurs, the surrounding temperature. So I'm going to go with the endothermic means that I absorb energy. And we can think of heat as being energy. So if we're absorbing, that means from the surroundings, I have to take in that heat. So actually, the surrounding temperature is going to decrease because the heat is going to go in to the actual reaction that's happening. Okay, number 5. What is the correct formula for nickel 2 oxide? I'm going to remember that the Roman numeral 2 is going to tell me my oxidation number. So if I look at my periodic table, nickel, which is Ni, remember if you don't know the symbol for something, you can go to table S. But if I look at nickel, I'm going to see that it has the plus 2 or plus 3 oxidation state. And so that 2 is telling me, well, the oxidation number is plus 2. So I'm going to go ahead and do my crisscross. Nickel's plus 2. Oxide is talking about oxygen, and that is minus 2. So I crisscross, and so I get Ni2O2. But remember, if I have both 2's, I'm not going to leave it that way. I'm going to simplify. So if they're both 2's, that means they could both be 1. So NiO is actually what I want. And so I look, that is answer choice A. 6, what IUPAC name for the compound ZNO? So I want to think, well, if I don't know what ZN is, again, I can go to table S. So maybe I'm going to table S here. But really, I know that zinc is Zn. So now I'm just thinking about the O. I know the O is oxygen, but I always have to have an "ide" ending. So I'm going to look for zinc oxide. Just see. 7, which of the following reactions will not take place spontaneously? If they ask you if something is going to take place spontaneously, I always want you to go to table J. And on table J, we're going to remember higher replaces lower. So if I take a look at table J, I'll pull it up here. What I want to see, again, if I'm just explaining what is spontaneous, something higher on the table will replace something lower. But now that they're saying will not, I'm going to go back and focus here. That means I want something that's lower trying to replace something higher. So I'm going to go at it by the answer right here. B, PB trying to replace AL. Let's find where the two of them are. I see PB is down here, but AL is up here. So that's something lower trying to replace something higher. So that will not occur. 8. Consider the following unbalanced equation. When the equation is balanced using the smallest whole number coefficient, the coefficient of HCl is. So I want to know about the HCl, but let's not focus just there. Let's balance the whole thing. So over here I see 2 Mgs, but here I have 1. So I'm going to put a 2 right here. I have 1 Si, I have 1 Si. I have 1 H. Over here I have 4 H's. And that would give me 4 Cl's, and I have 4 Cl's. So they're asking about the HCl. So I wrote a 4 in front of it. So D. Okay, number 9. An empirical formula represents. Well, this is a little vocab. Remember that empirical means that I'm going to be in the simplest form. So simplify. So if I simplify, let's see, qualitative information only. Well, I typically don't like onlys anyway. Lowest integer ratio of elements. Let's see, maybe. Only the metallic elements in a compound, no. And a multiple of the simplest ratio. So is it a multiple or is it the simplest? Simplest. B. 10. Pure oxygen reacts with metals to form. So oxygen, if it reacts with a metal, so any example of a metal, let's say I had sodium. Sodium, +1. Oh, -1. Or sorry, -2 if I crisscross. Na2O. Well, that's an example of it. So if I were going to name it, I would call it sodium oxide because I have to end in "ide." So oxide is my answer. 11. A reaction in which two substances combine to form a single product. So I'm going to focus here on combine and single product. That's going to represent synthesis. Combine and synthesis, I always want you to kind of think of those together. Single replacement, one thing tries to replace another. Double, two things switch. Decomposition, that's where I'll break down. So to explain that, you could just write that out. So 12, what is the chemical formula of iron 3 sulfide? So I remember that is Roman numerals going to show me my oxidation number. So I'm going to say iron is Fe plus 3 sulfide. Okay, that's sulfur. If I look at my reference table, I'm going to see sulfur is usually -2. It's the top number, so I take that one. I crisscross, I get Fe2S3. So I like choice D. 13. Which of the following is the formula of a compound? So let's think compound. Well, that's when I have 2 or more elements. Let's say 2 or more different elements. And they have to be chemically combined is usually how we term it. So I'm looking, that's just oxygen, that's just Mn, which is manganese, that's just Fr, LiH, lithium hydroxide. That's 2 elements. So D's the answer. 14, which of the following is a synthesis? We learned above that synthesis means I'm going to combine, and I'm going to look for one product. So if I look, I'm scanning B. A would be a single replacement. C, single replacement. And D would be a decomposition. 15, 2 molecules of hydrogen. So 2 molecules of hydrogen. Well, let's remember hydrogen is part of the 7H club. We want to remember that means it's diatomic. So if it's diatomic, then it's H2, but I have, remember up here, 2 molecules of it, so 2 H2s. So, choice C. 16. Which formula is correctly paired with its name? So I want to remember that if I'm ionic, I might use Roman numerals. So let's write that down, Roman numerals. If I'm covalent, I will use prefixes. And everything's going to end in "ide." So let's see, K2O. Well, K2O would be ionic. I see diphosphorus. Nope, I don't like diphosphorus, so A is out because ionic. No prefixes. Maybe we'll add that. No prefixes. MgCl2, magnesium chlorine. Ooh, I don't like that ene because I have to end in "ide, so I'm going to get rid of B. Copper 1 chloride. Let's just make sure that this Roman numeral is correct. If you reverse your crisscross, you can kind of see what it was. So that would be Cu plus 2 and Cl minus 1. So I actually don't like that because that's not the right Roman numeral. So C is out, so I hope it's D, but let's check it out. Iron 2 oxide. That would, let's try it. Iron, Fe, plus 2 because of the Roman numeral. Oxygen's minus 2. If you crisscross, you get Fe2O2, and then I simplify. So yeah, I like that. 17, what is the total number of atoms of oxygen? So I'm going to focus on the oxygen in the formula MgClO4 6H2O. So this is a hydrate, just to know that, because I see the water. And I'm going to focus on my oxygen. So here's some oxygen. So I have 4 O's, but I have them times 2. So right here I have 8, and here I have 1 O, but I really want to remember that there's 6 of them. So I also have 6, so 8 plus 6 is 14. Okay. 18. What is the name of a compound whose formula is N2O5? I want to think that I have 2 nonmetals. So if I have 2 nonmetals, that means that's covalent. And we said above here that covalence can use prefixes. So N2O5, nitrogen oxide. Nope, I don't like that because I have 2 N's. So I have to say that. So dinitrogen, I like those. I'm going to get rid of penta. Remember, penta means 5, so that's out. So these are good with the dinitrogen, and let's just think O5. So dinitrogen oxide or pentoxide. Ooh, I like that pent because there's 5 oxygens, so C. 19, given the balanced equation representing a reaction, what is the mass H2O produced when 10 grams of H2 completely reacts with 80 grams of O2? So what this really is the law of conservation of mass. So law of conservation of mass means mass is not created or destroyed. So whatever I start with, I have to end with. So if I have 10 grams of this, and I have 80 grams of this, well, I started 10 plus 80 with 90 grams. I started with 90 grams, that means I have to end with 90 grams. So, B. 20, what is the correct formula of dichlorine monoxide? So dichlorine, so Cl2 monoxide, so 1O. So Cl2 would really be O1, remember? So Cl2O is what I'm really looking for. Cl2. Oh, choice C. All right, moving on to the short answer. Almost there. Okay, so it says balance the equation using the smallest whole number coefficient, so they want me to balance it. That's what's important. Let's start here. Let's figure out who I only have in one place. So C's I have in 2 places. H's, we have 2 places there, but it's only in one of the compounds. And O's, I have O's in both. So H seems like my best bet. Let's see, I have 5 plus 1. I have 6 H's here. I have 12 here, so I'm actually going to put a 2 here. That balances my H's. So now, let's start next with let's do the C's, because if I have 6 C's here, and I have, let's see, I already have 4 of them. So I have 1 more here. So if I put a 2 here, that means I have 2 C's plus 4 C's. That's 6, and that gives me 6. So now I'm looking and say, okay, but last is my O. So I have 6 here. Well, I have 2 right here, and I have 4 right here. So 4 and 2, that's 6. That's balanced. You can either leave that empty or you could put a 1 in there if you wanted. And then so identify the type of reaction for 22. The type of reaction, I want to think, is it synthesis, decomposition, single replacement, double replacement? I see starting as one thing, and I'm breaking down, so this is a decomposition. Okay, so we should probably read this because it says the following goes for 23 and 24. So it says, in an investigation, a dripless candle is masked and then lighted. The candle burns. A small amount of liquid wax forms near the flame. After 10 minutes, the candle flame is extinguished and the candle is allowed to cool. The cooled candle is masked. 23, state one observation. So one observation, so that means I'm going to go up here. That indicates a chemical change. I don't think a chemical change is something I can't take back. So they told me that the candle burns, and when something burns, it's chemical. So I like that. Candle burns. Or you could say the flame, kind of reference that. 24, identify one physical change. So physical is something that I can take back. So it says that the liquid wax forms. But remember, wax, it gets solid and then it can go be liquid when it's hot and then I can go back to solid. So that's a physical change. I can put it back. So liquid wax forms. All right. So the next 25 and 26 go with this. An experiment, 2.54 grams of copper completely reacts with sulfur, producing 3.18 grams of copper to sulfide. So it says determine the total mass of sulfur produced. So actually, I think what's going to really help me is going to be if I write out what they're telling me happened. So they told me I had copper, so Cu, and it was going to completely react. So that's why I put the plus sign. It was sulfur. And so I'm going to draw my arrow because it produces 3.18 grams of copper to sulfide. So I'll do that over here. Copper plus 2, sulfur minus 2. If you crisscross that, you get 2 Cu2S2, so you simplify Cus. So let's look at it more like this. I have 2.54 grams of this. I have 3.18 grams of this. I don't know how much I have of this. So remember that law of conservation of mass. That means that whatever's on this side equals this side. So 2.54 plus something has to be 3.18 so that the mass is balanced on each side. So all I have to do is basically solve for that question mark, which is really like an x. So I'll say, well, if I subtract 2.54 from this side, oops, not that. Then I subtract 2.54 over here. So if I do that, I get my question mark, which is really like my x. I'm going to get, let's see, 0.64. 0.64. So that's my answer, 0.64. Law of conservation of mass. 26, write the chemical formula of the compound produced. Oh, we're in luck. They want the formula. I already wrote it over here. Cus. Perfect. Okay, so I see an equation here, and it's got rust. Okay, forming rust. Balance the equation using the small whole number coefficients. All right, balance it. Easy peasy. We can do this. So 1 Fe here, 2 are here. But actually, take a look here. 3 O's, 2 O's. I don't like an odd number versus an even number. So I'm going to put a 2 right here because I'm automatically going to make this O be even. So actually, now let's do my O's. So I have 2 times 3 would be 6. And I have 2 here, so I'm going to put a 3. And then that would give me 4 FEs, because 2 times 2, 4. So I'm going to put a 4 right here. So my coefficients are 4, 3, and 2. 28. No, not 29, 28. Identify the type of reaction. So again, the type, decomposition, synthesis, single replacement, double replacement, maybe combustion. So let's see, I have 2 things coming together to form 1 thing, so synthesis. Okay, let's see what this says. A tablet of 1 antacid contains citric acid, H3, C6, H5O7, and sodium hydrogen carbonate, NaHCO3. When the tablet dissolves in water, bubbles of CO2 are produced. The reaction is represented in the incomplete equation below. Okay, so it's incomplete. Let's see, I'm going to have to figure that out. So 29 says, complete the equation by writing the missing chemical formula. All right, I got to figure out what's missing. So this is going to be a task. Let's first figure out what I have on each side. So over here I see 3 H's, but I also see another 5 over here, so that's 8. But over here I have another 3. So in total I had 8 and 3. So I have 11 H's. Now I have 6 C's here and another 3 C's here. So I have 9 C's. I have 7 O's. I have 3 O's here, but times 3. So I have 9 O's and another 7. So that is 16 oxygens on this side. I'll draw my arrow because let's see what's on the other side. I have 3 NAs. Oops, over here I forgot my little NAs. I had 3 NAs. Oh, silly me. Now over here, 3 NAs. Look, it matches. Perfect. I have 6 C's here. I have another 3 here, so that gives me 9 C's. I see 5 H's. Just, well, 5 H's. I see 7 O's plus another 3 times 2 is 6. So 6 and 7 is going to be 11 O's. And that's it. So let's see who's missing. 3 NAs and 3 NAs, that's balanced. 9 C's and 9 C's, that's the same. But look here. 5 H's. Here I have 11. So that means something plus 5 gives me 11. So I need 6 more H's. Because 6 and 5, there's my 11. And then here I see 11 O's. I got 16 O's over here. Wait. That leaves me with 5 O's. Let's see. Something went around here. So, oh, that's why I can't add. Silly. I wish you guys could talk to me. When I have 6 and I have 7, give me 11. That gives me 13. So 13 versus that. So I need 3 O's. My goodness. I need 6 H's and I need 3 O's. Okay. 6 H's and 3 O's. Ooh, but I see a 3 right here. So really, I'm going to divide these by 3. So I need 1 O and I need 2 H's. What do you know? H2O. That's what's going to go in there. H2O. Again, wish you guys could help me count. Okay. 30 says determine the total number of oxygen atoms in the reactants of the balanced equation. Okay, well, we had enough trouble the first time. Let's see. Oxygen in the reactants. So on this side, we said on the reactant side, I had 16 oxygens. So 16. 31. State evidence that a chemical reaction occurred when the tablet was placed in water. All right, chemical reaction. We said that I can't undo that, so let's go back, look over here. Ooh, you know what I like? Bubbles of CO2 were produced. That is always a great indication of a chemical reaction. Things like color changes when things explode, or you see smoke like gas. So let's see. I like that gas bubbles were produced. Okay, so, all right, magnesium metal reacts with hydrochloric acid to produce hydrogen. Balance the equation for the reaction using the lowest whole number integers. I see my reaction actually down in 33. Let's skip there. So I have 1 Mg, 1 Mg, 1 H, 2 H's. All right, I'm going to put a 2 right here. 2 Cl's, 2 Cl's. I think I'm done. Just put a 2 right there and you're done. If you're really feeling frisky, put 1s in there. But otherwise, just that 2. Let's go back to 32. What type of chemical reaction? Okay, type. We can do this. We've done this a few other times. So let's say I have one thing. I have a compound. I have a compound of one thing. Wait a second. That Mg was by itself. Now it's together with the Cl. So, wait, the Cl was with the H. Now the H is by itself. Okay, that must mean Mg came in, kicked out that hydrogen, so the hydrogen get out of there. And so we have ourselves a single replacement. All right, guys, it has been so fun doing this Regents Prep with you. Hope that helps. You guys are going to do awesome on the Regents. See you soon.